All right, the next transformation is the horizontal translation. So think about a horizontal line. That is a line that goes side to side. So this means whenever we move the graph left or right. So the place we're going to look is the h value. Well, real quick, let's go back to the top and look at what we saw. We saw that on this one, we moved it to the right 2. And when we moved it to the right 2, we had a negative 2 on the inside. That may feel a little backwards for us because we probably think, well, negative 2, that means we're going to go to negative 2. But that is not what happens because it's in those absolute values. So whenever we have something, we have an h value that is inside the absolute values, we actually do the opposite. We're going to think opposites here. Think opposites. All right, so the two things are x minus h and x plus h. If I see x minus h in those absolute values, that means I'm moving my graph to the right, or I'm moving the vertex to the right. And if I see a plus h, that means I'm moving it to the left. So again, we think opposites. One way we remember this is that h stands for hips. So I know it's kind of silly, but if you move your hips to one side, your shoulders and your torso all go to the opposite side. So if I move my hips right now, my shoulders are going to go to the opposite side. That's how we remember that the h value, whatever's on the inside, we do the opposite. So if it's a minus, we go right. If it's a plus, we go left. Lastly, vertical translation means moving the graph up and down. So that means we are going to look at the k value. And for the k, we look at exactly what we're given. So go back up to number 2. We said that this moved down 2, and we saw a minus 2. So I see a minus 2, and we moved it down to negative 2. So that means that the k value, we just do exactly what we're given. We don't do the opposite like we do with the h. All right, so for this one, we have a positive k tells us one thing, and a negative k tells us another. If I see plus k at the end of my absolute value function, that means I moved it up. If I see minus k, that means I moved it down. So the silly thing we use to remember this is think about your knees. If I bend my knees, my whole body moves down. And if I straighten them, my whole body moves up. So we think about how our knees are normal. If I bend my knees down, I go down. So that's like having a minus takes us down. If I straighten them, they go up. So that's like a positive goes up. So hips, we think opposite. Knees, we think of normal. All right, let's put all of these into practice. First with our function, y equals 3 times the absolute value of x minus h, and then a minus 2 at the end. We want our vertex. We want to know if it opens up or down, and we want our slope here. So first of all, our vertex. We're going to get our vertex from hk. So let's remember our transformation function is a times the absolute value of x minus h plus k. Our vertex is going to come from h comma k. Notice what we have here is a minus h, but what we took for our vertex was a positive h. So whenever I do my vertex, I'm going to take the opposite sign of h, but not of k, just the opposite sign of whatever's on the inside of the absolute values, because we said the hips are opposite. So let's look at what h and k are here. I see my h is a negative 1, my k is a negative 2. So for my vertex, I'm going to take the opposite of h. I have negative 1, so I take positive 1. Then for my k value, I see a negative 2. We remember that the k, the knees, are normal, so we just take exactly what we're given. We only take the opposite of the h. So there's my vertex. Now let's talk about if it opens up or down. This has to do with reflections. So for a reflection, we said it's going to open down if this a value is a negative. So if my a value is positive, if it's plus, it's going to open up. And if it is negative, it's going to open down. So if it opens down, it looks like that. If it opens up, it looks like that. All right, so let's look at what our a value is. My a value in this case is 3. Is that positive or is it negative? Well, clearly it is positive. So that means that it's going to open up. So my absolute value function is going to look something like that. And last thing is our slope. So we're going to kind of call it a slope, but it's not exactly a slope. And for this, we look at our a value. Whatever our a value is tells us what to do. Our a value is 3. And it's kind of like a slope because it tells us a rise over a run. But for our absolute value function, like for the ones up here, it tells us our rise, but then we run left and right. Rise, run left and right. So that's the difference here as opposed to a normal slope. So what does an a value of 3 tell us? It tells us we're going to go up 3, and then we're going to go over 1 left and right. And that's why it's different from a slope. We don't just go up 3 over 1, up 3 over 1. We're going to go up 3 and over 1 left, up 3 and over 1 right. And we'll see examples on the back of the sheet. All right, let's look at the next one. The absolute, nope, not absolute value. We have -2 times the absolute value of x plus 4, and then a plus 1 at the end. So first we want our vertex. If you feel like you can, then go ahead and pause the video and try to find the vertex, how it opens, and the slope. All right, now that you've found those, check them with my answers. The vertex, we take the opposite of what's on the inside. I have an h value of +4, so I take a -4. And then we just take whatever our k value is, which is a 1 here. Whether it opens up or down, we look at our a. Our a in this case is a -2. Well, if a is negative, that means it opens down. So here's what my graph will look like. Lastly, our slope. Our slope is a -2. So that tells us to go down 2, and then that tells us to go over 1, left and right. Down 2, over 1, left and right. Last one, go ahead and try number 3 on your own, and then check with my answers. All right, let's look at this together. Our vertex, I don't see any h value there. There's nothing inside with the x. When that's the case, we have a 0. And then for our k value, we take exactly what we're given, which is a -4. So there's my vertex, 0, -4. Now, does it open up or down? Well, I don't see an a value. Can we say a is 0? No, we cannot say that. If this was 0 times the absolute value of x, then we wouldn't even have this part of our function. So when there's no slope there, we know that there is an implied 1. Well, that is positive, so that means it opens up. We know our a value is 1, so what does that tell us to do for our kind of slope? That tells us we go up 1 and over 1. I'm just going to put L and R for left and right. Up 1, over 1, left and right. Again, we're going to look at examples of this on the back. So let's go ahead to the back together. All right, on the back it says, graph the function, give the domain and range, and list the transformations from the parent function. So a few things here. We are going to kind of split up 1, 3, 5, and 2, 4, 6 to practice our different domain and range. So for 1, 3, 5, we're going to use set builder notation. And for this column, 2, 4, 6, we're going to use interval notation for our domain and our range. And then last thing I want us to remember is the transformation function that we talked about on the front, y equals a times the absolute value of x minus h plus k. We're going to use this to graph our functions, and I'll show you how to do that. So let's start with y equals the absolute value of x minus 2. Now I know we graphed that one on the front with a table, but now we're going to graph it without a table. So the first thing we need to do is find our vertex. So remember our vertex is h comma k, and we take the opposite for h. So what do we see here for our h? I see a -2, so I'm going to take a +2. What do I see for my k? There's actually nothing there at the end. So when there's nothing for our k value, we take a 0. Our vertex here is 2, 0. And then we need our a value because that's kind of like our slope. So what's my a here? When there's no a, we know there's an implied 1. I have my vertex, I have my slope, so now we're going to graph that. We're going to go to 2, 0, so that is here. Now my slope of 1 tells me to go up 1, and then I go over 1, L and R, left and right. So let's start on the right. I have my vertex. I'm going to go up 1, over 1, right. Up 1, over 1, up 1, over 1. But that's not all. We have 2 parts to these functions. So now that I went up 1 and right, now I'm going to go up 1 and over 1, left. Up 1, over 1, up 1, over 1. A common mistake that I see when people graph these is that they only pay attention to the right side and then they just have a line. We can't have just one line here. Absolute value is always going to give us a V. Alright, so we graphed our function, and that's all we have to do when we graph it is find the vertex and the A value. Now we want domain and range, and we're going to list the transformations. So first let's do our domain and our range. And on this side, we are doing set builder notation. Now, on the front of the page, what did we say our domain is for every single one of these? Let's think about it with this graph. My domain, I'm going forever to the left with that arrow, forever to the right with that arrow, because the domain is those x's. So my domain is going to be all real numbers, or x is an element of the reals. And then my range, I'm going to have my y values. So let's look up and down at my y values. I start at the bottom and I see the first thing is that 0. That's my y value of 0. Am I graphing the numbers greater than or less than 0? Well, it's the numbers going up, the numbers greater than 0. So I've got y is an element of the reals such that y is greater than or equal to 0. Close circle on 0, numbers are going up. So that is my domain and range in set builder notation. Last thing we need to do is list the transformations. So we just need to say what happened to this. Was there a reflection? The answer to that is no, because it's still pointing up. Was there a stretch or a shrink? Again, the answer is no, because our A value is 1. Our A value is not bigger than 1, and it's not less than 1. It has the same kind of slope that up 1 over 1 as our parent function. So then the next thing we ask is, did we move it left or right at all? Well, where does our parent function usually go? The parent function is usually at 0, 0, and then it usually goes up 1 over 1, up 1 over 1. So I'm just going to sketch our parent function here. Starts at 0, 0, and goes up 1 over 1, up 1 over 1. That's the parent function that we looked at on the front of our sheet. So how did I get from the parent function to the new function? We translated it to the right 2 units. So we went to the right 2 units. Did we take it up or down any? We started here, and all we did was move it right. We didn't go up, we didn't go down. So this is actually our only transformation, right 2 units. I've got a few questions for you to answer on some functions and then come back to the next video and we'll finish off our notes.